Hi everyone. In this video, let's understand pessimistic locking and optimistic locking in the simplest way possible. Imagine two users are trying to update the same database record at the same time. Consider user A and user B are updating the database record at the same time. If both save their changes without any control, one user's changes might override the others, right? This is called concurrent update problem or lost update problem. To prevent this, we use locking strategies. They are pessimistic locking strategy and optimistic locking strategy. Pessimistic lock assumes conflicts are likely and prevents them before only. Optimistic locking assumes conflicts are rare and detects them later. So basically, it locks the row on read, it locks nothing but versions everything. Let's understand this later. So, first of all, let's see about pessimistic locking. When you see the word pessimistic, what do you think? It means expecting the worst, right? So, here the database assumes conflicts are likely. So, as soon as transaction reads a row for updating, it immediately places a lock on that row. No other transaction can modify that row until the first one commits or rolls back. You can think of it like borrowing a book from library. When you take a book, when someone is requesting the same book, until you give it to the library, they can't take it, right? Let's take a real-time example where this pessimistic locking is used. Consider a movie ticket booking system. User A starts to book seat A12. This is A12, A13, A14. User A tries to book seat A12. When he tries to book, system locks that seat, right? When system locks that seat, he's still completing the he still completes the payment, right? For example, user B also tries to book the same seat, but its query does not fail because it is waiting in the queue. For example, request of user A is currently running. Request of user B is in the queue. Until it completes this, it won't go to request B. So until request A completes, it locks the record. So user B has to wait. When user A completes the booking, the seat becomes booked. Now user B's request from the queue goes to the booking state, but the application tells user B it is no longer available. So no conflicting updates ever happen because the conflict was prevented from beginning only. So here two updates were never in flight at once. So nothing had to be undone. So there are some trade-offs. There are pros and cons for pessimistic locking also. If you see pros, prevents conflicting updates completely. So there will be no conflicts at all when we do pessimistic lock. This is very safe for highly critical operations. Like highly critical operation, I mean, like transactions, which should not be done double. So those are very highly critical operations, right? Cons. There are some cons also. Lower concurrency. Users wait. Here, no parallel execution happens. So users have to wait until first user completes the transaction. So it is lower concurrency. It can reduce the performance because as the waiting time is more, the performance will be slow. If a transaction is held too long, like failed transaction or pending transaction, deadlocks may occur. So deadlocks, if locks are held too long. These are the cons and pros of pessimistic locking. Let's look at optimistic locking. So optimistic means opposite of pessimistic, right? We expect everything to go well. Here the database assumes conflicts are rare. So it does not lock the row while users are reading or editing. Instead, each row carries a version. Let's see what is version. Right. Let's take an example. Let's say Alice and Bob are reading a record. Both receive version 1 of the record. Alice is editing the record, reads version 1 and starts editing. Bob also starts editing the record. Notice that here nobody is blocked. both are working independently. Consider Alice saves first. They wrote update employees, set name is equal to John Smith, version is equal to 2, where ID equal to 1 and version is equal to 1. So the version she read still matched because version 1 exists in the database record. So her write was safe. Now the database record changed to ID is equal to 1, name is equal to John Smith, version is equal to 2. Now Bob also completes his update. Now Bob clicks save. Here update employee set name is equal to Jonathan, version is equal to 2, where ID is equal to 1 and version is equal to 1. But there is no version is equal to 1 for ID equal to 1, as it is already changed to version is equal to 2. So the app raises an optimistic lock exception and asks Bob to refresh the screen or refresh the application and try again. Bob's changes are rejected instead of overwriting Alice's. So a rejected save is the point. Alice's change survives. There is an interview question. If user A is editing, can user B still read the record? Yes, that's one of the biggest differences. A's changes are not committed yet, so B still reads version 1 exactly as A did. Only after A successfully saves, then the database record becomes version 2. So optimistic locking allows multiple users to read and even edit in parallel, but after saving one of the version, then only the save is checked. So anyone reading from that moment, when the new version is saved, gets version 2. Another common interview question is, what if both users click save exactly the same time? Even then, the database processes write requests one after another internally. Because, for example, consider write A reaches the database, finds version 1, row becomes version 2, write B looks for version 1 which no longer exists. Here, even in milliseconds, it will check. Here you can see 0 milliseconds, this is 1 millisecond and 2 millisecond. So here writes are serialized internally. This is very important. So there is always a first and a second. So the second request checks for the updation, but it's not possible. So it returns 0 rows, right? So when to use each? Pessimistic locking is mostly for conflicts when conflicts are frequent or a mistake is very expensive, because that mistake can cost anything. Optimistic is used when conflicts are rare and workload is mostly read heavy, not write operations. So mostly it's used in banking transactions because multiple writes may not be allowed. Okay. Inventory management, and one more thing, trades, right? Buying and selling of trades, seat booking and payment processing. Okay. So one payment should not happen multiple times reaching the server. It can lead to multiple transactions. So these all should be done pessimistic locking. Optimistic locking like profile editing, product catalog management, content management systems, and most enterprise web apps use optimistic because mostly it's dashboards and all, so they'll use optimistic locking. So when in an interview asked about pessimistic locking and optimistic locking, let's see assumption. Conflicts are likely for pessimistic and optimistic conflicts are rare. Locking. Pessimistic locks the row immediately. Optimistic, no lock on read or edit. We have seen already. And mechanism. Other updates wait in the queue. Optimistic version number, or we use timestamp sometimes. And cost. Here cost is safer but slower. Optimistic faster and more scalable. Now, so if you want to remember, one line memory trick is pessimistic is basically lock first, work later. Optimistic is basically work first and check later. So it will show the conflict. It will know the conflict before only, and it is after conflict after. Okay, this is the fundamental difference. You can remember like lock first, work later, and work first, check later. So this is the difference between pessimistic and optimistic locking. Thank you for watching.